In this video, I am going to teach you discrete time Fourier transform, some properties that is being used to solve a few questions asked in GATE exam. So here I start with some one question that is asked in previous year GATE exam. The question is the sequence xn is given. This is discrete time signal given. It is a unit step sequence, of course, and is convolved with itself to obtain yn. So what we have to find, summation minus infinity to infinity yn, what will be the value of this? So yn is what? Yn is just the convolution of this signal with this signal itself. Okay, fine. So we see that this type of question, if asked in exam, that where we have to find out the summation from infinity minus infinity to infinity of some sequence, so we must think in our mind that this type of relation is being used in GATE transform or discrete time Fourier transform, the well-known expression that you know. Let us see the expression first. The expression of DTFT, discrete time Fourier transform, is written as y exponential j omega is equals to n equals to minus infinity to infinity, the summation yn exponential minus j omega n. So here if we put omega equals to 0, this terms becomes 1, and the expression becomes, means if we put omega equals to 0, the term becomes y exponential j0 equals to summation minus infinity to plus infinity yn. What we have to find here? We have to find here minus infinity to infinity summation. So we can easily deduce that y exponential j0 reveals the same thing. So if we can find out somehow the value of DTFT, discrete time Fourier transform, means y exponential j omega of this signal, yn signal, then we can, by putting omega equals to 0 in that equation, we can easily find out the final value of this one. Okay, another thing that we can use is Z transform. Z transform is similarly explained. The expression is minus infinity to infinity summation yn z power minus n. So if we put 1, if we put instead of z here 1, z equals to 1, y1 becomes n equals to minus infinity to infinity yn. So either using Z transform relation or using DTFT relation, we can easily find out this expression value. So what we will use here, I am going to describe only DTFT, so I'll focus on this DTFT, and the relation is hereby y exponential j omega minus infinity to. So we will keep reminded that if we somehow find out the expression, the DTFT of this signal, then we can easily, by putting omega equals to 0, we can easily find out the value of this. So now I start to find out the value of the DTFT value of this expression. Okay, so here we start. First of all, the given xn signal, let us recheck this signal. Xn signal is 0.5 power n un. So first of all, a power n un, the DTFT of this type of signal is 1 upon 1 minus exponential minus j omega. So for the given signal xn equals to this, the DTFT will be x exponential j omega, means 1 by 1 minus 0.5. Here it was a, so here it is 0.5, so we can easily put 0.5. So 1 minus 0.5 exponential minus j omega. Okay, now there is a property that if any convolution in time domain, time sequence, if we do the convolution, then in discrete time Fourier transform, means in frequency domain, the signals are being multiplied. So x1 and convolution x2n can similarly be, means it's DTFT, it's discrete time Fourier transform of overall signal will be just the multiplication of individual discrete, means discrete time Fourier transform of individual sequences, that's the multiple of these two. Okay, so for the given signal, as we know that the same signal is convolved with itself, so yn equals to xn convolution xn, so its DTFT will be just the multiple of the discrete time Fourier transform of these two signals. So y exponential j omega equals to multiple of x exponential, means x exponential j omega square, and we have already find out x exponential j omega value, so its square means we have got the desired result y exponential j omega. And as I had said earlier that we have nothing to do now, we have just to put omega equals to 0 in this expression and the final result will come. So summation minus infinity to infinity yn equals to y exponential j 0 means we here instead of omega we will put 0. So by putting 0 here it becomes 1 upon 1 minus 0.5 square, so final value will be 4. So the answer of the given question will be 4. So thank you for watching the DTFT properties and its relation. I hope that this type of question can be done by you, and keep watching, keep subscribe our channel for the upcoming videos. Thank you.